So it's 0.2 in the short run and 0.7 in the long run. You write with a mouse. Okay? And so then we are supposed to figure out what happens to the quantity demanded in the short run. So we have the price change. It goes from $1.50 to $2.20 a gallon. Okay, $1.80 to $2.20 a gallon. So what equations should we start with here? We have to have the midpoint equation, and we also have to have the equation for price elasticity of demand. So we know that our equals is 0.2, correct?
Yep.
And we can figure out, using the midpoint method, what our percentage change in price is, okay? So we just have to do a little algebra here. This is basic algebra 1, right? So what is our percentage change in price? Okay, 20%. 20% divided by what gets us 0.2? Isn't it price over quantity gets us percentage change in price over percentage change in quantity gets us elasticity? We know what our elasticity is, so our X is the percentage change in demand. A 4% change in quantity demanded?
Yeah.
Davis says no. Davis says 100% change in quantity demanded?
No, it's quantity demanded over price.
So our percent change,
And quantity over percent change.
is it quantity over price or price over quantity?
Quantity over price.
Oh. Okay. So if it's quantity change over price change, and we said that our price change is 0.2, our quantity change is our X, and the whole thing is equal to 0.2.
No. Our percentage. Oh, yeah.
Okay. Now there's much confusion.
20.
You guys got to decide how we're doing this math.
4 over 20 equals 0.2. So it should be, I said 4 over 4%.
So,
Yeah, 'cause even if you did a 0.2,
algebra folks, how do we get rid of our multiply both sides by 20? So then X equals
4%. No. Yeah. 4% change.
yeah.
It's 4%. You put the 20 in as a percentage.
Yeah, I'm gonna do some explanation of that later.
Okay. So by the midpoint method, we figured out that we had a 20% change in price. So our change in quantity over our change in price. We don't know the change in quantity, that's X. The change in price is 20%. So then to solve for X, you multiply both sides of the equation by the denominator?
Yeah.
Denominator. And 0.2 times 20 is 4, and because we're looking for a percent, it's 4%. Check the answer key. It's 4%. Yes? Hey,
Was that for short run?
short run. So now we have to do the whole miserable thing over again for the long run. Do our dollar amounts change? No. So, all we do is do the same thing. X over 20 equals 0.7 now. And we multiply both sides times 20, and we get X equals, what? 14%. And this is the short run, or this is the long run. And this is the short run. So, is our demand for heating oil more elastic in the long run or the short run? We know the answer to that because we started with the elasticities. It is more elastic in the long run. Now you know how much more elastic? In the long run, people change their demand for heating oil by 10% more than they do in the short run. That's pretty significant. What are they doing? Wearing long johns to bed instead of running the furnace? Who knows? Doesn't matter what they're doing, but we know now how much their quantity demanded changes. Okay? It's just basic algebra. You just have to know both equations and know them cold. Okay? Guys, many of you are not spending time every night studying this stuff. And you have to. If you had those equations committed to memory, this would have been so easy, almost kind of a laughable joke. It can't be this easy kind of thing. But if you're struggling to remember what's in the equations, then you're not going to remember what equations you need to use. Okay? Every night. I don't load you up with homework like an AP English class, but you've got to put in the time. Okay? All right, so to be, correct? Do we need to discuss why it depends on the time horizon? Because you can find other solutions. Maybe electricity is cheaper and they buy electric space heaters instead. Maybe they're some of those bozos who do something like bring the fire pit inside and then kill the whole family with carbon monoxide poisoning, right? That'd be good. Or we can, I don't know, let's bring the grill inside to cook. Carbon monoxide. Yeah, you
What
cannot,
about fireplaces though?
because it has a chimney.
Oh, I was like, why are people bringing those inside? I was
Isn't
like,
that like common sense?
gotcha.
What?
Isn't that common sense not to do that?
No, apparently not. Families die every winter and after every natural disaster where it's
People leave
cold.
their babies in cars and they die in their cars. You think it'd be common sense to
Not leave your baby or your pet in the car.
carry that thing around for 9 months and you can't remember to get out of the car? Yikes.
All right, so now we go on to number 4. Price change causes the quantity demanded of a good to decrease by 30%. So we've got 30% on the top of our equation now, right?
Negative.
But does that matter? Okay. While revenue increases by 15%. Is the demand curve elastic or inelastic?
Are we using the same equation as we did last?
I don't know. Do we use the same equation?
No, 'cause it's
Why
talking
not,
about-
Davis?
It's talking about demand, so you need to look at the quantity.
No,
Last time we used elasticity supply, now we use elasticity demand.
wait, the
No, it's
total
elasticity
revenue.
of demand last time, in 3. It says, suppose the price
No.
elasticity of demand.
Price times quantity equals revenue. This is a revenue change, not a price change.
Yes, you do not use the same equation. Price times quantity is revenue. But you can use that equation in couple with our existing equations. It's a revenue question. But price times quantity is revenue. And they told us how much the quantity changed, correct? And they told us how much the revenue changed. So we still have to figure out how much the price changed. So, more mouse writing here. If price times quantity equals revenue, and it told us how much the quantity changed,
30%.
and how much did the revenue change?
15.
Okay, so negative 30p equals 15, so we end up with price changed by, price went down by, yeah, since 30 was a percentage. Yeah. Price went down by 0.5%. Okay? So now we know how much quantity changed, right? And we know how much price changed.
So that's 60.
So our elasticity is
60.
So is this inelastic or elastic?
Very elastic.
Very elastic. Price went down 0.5%.
And then that whole.
Yeah, and quantity went down by 30%. That's pretty elastic. Common sense should be able to tell you that's stinking elastic. Right? But how did revenue go up by 15%? If it's that elastic, that doesn't make
Is that
sense.
quantity divided by price?
Yeah.
It's because price went down, so more people bought it, and then the more people buying it overcame the.
But the quantity demanded went down by 30%. Isn't that what it told us?
Price probably went up by 0.5%. Not down.
Yeah.
Yeah, price.
So it must have been a pretty pricey thing in the first place, huh?
Yeah.
So what happened if the price went down?
Price probably went up to cause the decrease in quantity demanded, because if it's that elastic, price has to move the opposite of quantity demanded. Yeah. Yeah. Okay. All right. So now number 6. Did we skip 5 or did we do 5? We did 5. All right. Equilibrium price of coffee mugs rose sharply, but the quantity was the same. 3 people tried to explain the situation. Which one was right? Price went up very, very sharply, and the quantity stayed the same. So how many of you said Valerie has it right? How many of you had no clue how to even approach this question? How many of you said Valerie? How many of you said Marion? Oh, Marion, no votes. How many of you said Billy? There are a lot of you who didn't even gesture at me. All right, so let's take them one at a time. Billy said demand increased, but supply was totally inelastic. What does that look like? Looks like that, correct? So if price went up sharply, quantity didn't change at all, that would explain it, wouldn't it? Okay, let's evaluate what everybody else said. So this is Billy. What did Marion say?
Supply and demand increase.
Marion said supply and demand increased.
That would not be. They both go up.
Yep, so we get an increased quantity there right away. So Marion's no go. Then what? Valerie?
Supply decreased, but demand is totally elastic.
Valerie said supply decreased and demand is totally inelastic. But the price went up. Can't happen. Supply decreased, the price went down if demand is inelastic. And
Wait. You said the supply decreased, but you put the supply 1 as the first line and supply 2 as the
oh, yep, sorry. So here's our demand. Huh. Could Valerie be right?
Wait, I'm confused. What was the last graph you just showed us?
That's Valerie's prediction that supply decreased and demand was inelastic.
The first one was a mistake?
That's the first value. Second.
So, is it just how you argue the question that would give you the right answer then?
Well, Billy said demand increased, so let's see what that does. We left that part of it off. Demand increases does what?
also increases price.
For the value.
And the quantity stays the same in both of those. So they're
Both
right.
You have to say they're both right to get that one right, or both.
And for those of you who had no clue how to figure this one out, how did we figure it out? Okay, next. 8. Maria is going to spend 1/3 of her income on clothing. Let's stop right there and evaluate that.
Same girl, same.
Real question, how much is she making?
Doesn't matter. She's spending 1/3 of her income on clothing. Luxury or necessity?
Oh, necessity.
Well, shoot, I'm fixing this one. Clothing. Clothing is a necessity. Is it broadly or narrowly defined? Okay, are you following here? We got to stop and evaluate everything. So she's going with a broadly defined necessity. Are there substitutes? Are there clothes substitutes available for clothing?
No.
Other than fig leaves? No.
So it's a
Fan dancing? Vegas style?
low elastic.
Alright, so what is her income elasticity of clothing demand? Meaning, as her income changes, how elastic is her demand for clothing? Not very, because it's a broadly defined necessity without clothes substitutes. I don't care how much her income changes, she still needs clothing. Okay? What is her price elasticity of clothing demand?
Wait, I don't understand. It's not very much because it doesn't matter.
How much does her demand change based upon changes in her income?
Wait, no, change on our price, based on our price.
No, she asked about it.
Oh.
She took us back to A. So now B, what is her elasticity based on the price of the clothing? It's still low. Her elasticity is still low. It's probably not perfectly inelastic, but it's probably relatively inelastic. We're not specifying whether she's shopping at Brooks Brothers or Goodwill. She just needs something to cover her nakedness. Okay? If her tastes change and she decides to only spend 1/4 of her income on clothing, how does her demand curve change?
Her income doesn't change though.
Her income didn't change, she just changed how much of her income she wants to spend.
So it went from 1/3 to 1/4.
So Dayton is hypothesizing maybe that her demand curve shifts to the left. Saying she wants to buy. Davis says her demand curve doesn't change. She still needs clothes,
The
says.
demand doesn't change, it's just how much she's spending.
Yes.
Yeah, because she can go from buying the same amount of clothes with Mike to going to Walmart.
And it's 11 o'clock. Bye-bye. We will continue this tomorrow. Your quiz will be on Friday.
God bless. Yes. That's the
Hey,
best
Siri.
answer.
Set an alarm for 1:30. Hey Siri. Set an alarm for 11:55.
Set an alarm for 11:55 a.m.